Now that we know a little bit of theory about polymorphism, let us apply this to our fraction library. It has been mentioned that polymorphism can be implemented using either inheritance or overloading methods or constructors. We will delay our implementation using inheritance until the time we actually perform a downward inheritance of our fraction base. Now let us implement polymorphism in our fraction library using overloaded methods. This should include constructors and overloaded operators at least. Let us start with our Visual Studio. Let us go to constructors first. But before that, let us complete the XML documentation that we forget to add before our last commit to our GitHub, which is under methods. This one. What do we do? Just press /3 times. So this toString, what is it doing? It is converting the numerical content of the fraction into string so that it can be displayed properly on console. And what is the return or the output of this method? It is a string that contains numerator in brackets if, okay, why not we put denominator first, that contains numerator followed by the denominator separated by a slash, which is this one, and put in brackets if any of them is negative. I hope that is clear enough. Next, let us overload our constructor so that we can have a flavor of polymorphism. The constructor that we already have is the default constructor without any parameter. Now we want to allow the user to call a constructor with two parameters. One is to be assigned to the numerator and the other one is to be assigned to denominator. So in this case, there will be only two constructors. One constructor will not receive any parameter, so it default to fraction of 0, numerator 0 and denominator 1. The other one is the constructor with both numerator and denominator are specified, and that value is given to that respective field. Okay, let us code this. So the second constructor is going to take two integer. The first one is numerator. The second one is denominator. In this case, we just assign the given num to the underscore num field. Denom we assign to the denom field. In this case, if denom is 0, the value that's given to denom is 0, we are supposed to raise an exception because a denominator of 0 is not a valid fraction. It is an infinity. And if both numerator and denominator are 0, it is mathematically incorrect. However, we are not going to do that for now because if it is error in this case, giving 0 to denom, it is also error in this case when we give a value of 0 to denom in the setter for denominator. So we are going to delay that checking and also the raise of an exception or the throw of an exception when we include exception handling in this project. So that is it for constructor. Next, let us add the overloaded operators for the fraction. Let us start with addition of two fractions. Do you still remember the pattern or skeleton for overloaded operator methods? It has to be public, static, and it has to return the same fraction. In this case is fraction base, but it is a method for operator plus, and it is named LS, LHS and RHS, left hand side and right hand side, but I would like to rename it to operand 1 and operand 2. Then what is wrong here? Okay, just not returning any value yet because we have not finished. So to do it step by step, we instantiate a new fraction base result. Okay, then we assign result dot numerator first. Now to add two fraction, you need to equalize the denominator by multiplying them and also the numerator. So operand 1 numerator will be multiplied by operand 2 denominator and then added with operand 2 numerator multiplied by operand 1 denominator. So what is suggested is correct. Then denominator is simply the multiplication of denominators from two operands. Let me align this. And then, of course, at the end, we need to return the result. Let us try this one. Sometimes this kind of error occur. Let me clean solution and then rebuild again. There shouldn't be any problem. Just now was resolved already. And why did it say fraction library was unknown? I have no idea. This usually happens if we continue a development after a long stop. Perhaps 1 or 2 days after we stop one development, if we continue, we might see something unpredictable like this. And yes, this video is not shot in one continuous take. I actually combine them at editing. Alright, let us test this with the driver. Let us put a blank line over here by putting a blank right line. Then we declare fraction base, two fraction base at 1 new. Then we can straightaway test our overloaded constructor. Let's say we want to add 2 over 3. Let's say 4 over 5. Very obvious number. Then we can declare one more F3, which is actually F1 plus F2. So this is the overloaded or the use of overloaded addition for fraction base. So next, let us print it. We already have two string. We just do a right line and then print the two string. Not a frac, it is F3. What should we get? What is the expected result? It has to be the denominator is 15, 12 plus 10, which is 22. So it's 22 over 15. Save it, rebuild solution, run it. Yes, 22 over 15. So it is tested. Next, it should be easy to create the operator subtract. So let us continue with operator subtract or minus. We can just copy the code for operator plus and just make one little editing, which is this one, change plus to minus. We will do the testing for this part when we actually put the unit test for these overloaded operators. When we continue with the actual fraction class, not the fraction base. So this is operator subtract. Next is operator multiply. So you see, you need to very good with maths. You need to know how to calculate multiplication of two fractions, which is what? The result numerator is actually a simple multiplication between numerators of operand 1 and 2. That is it. Sorry, this is numerator. Alright. I hope that is correct. We will test this using unit test. Unit test is perhaps in the next video. Then division. Division of two fractions is almost identical to multiplication, but the multiplication is cross. Numerator multiplied by denominator, denominator multiplied by numerator across operand 1 and 2. This is denominator, this is numerator. We have done with the basic operators for our fraction base. We will continue in the next video with a few more methods, or at least one more method, that is to normalize the fraction. And also, as I said just now, we want to continue with the unit test. And of course, to continue with the next inheritance from fraction base to fraction. Before we close our Visual Studio, let us commit all the changes to our GitHub. Say something about this commit: added overloaded operators for plus, minus, multiply, and division. Successful. Let us verify this on GitHub itself. Okay, this is the last commit. The operators is added with this one, and the methods is actually added with the XML documentation, and constructors are also the overloaded constructor. We should add that just now. Never mind. So it is updated in our GitHub. See you in the next video.